Welcome to the shop. We're doing some MIG welding today, and if you want your MIG welds to go better than they are, you're looking to improve, the 4 things we'll talk about in this video are really the main areas to focus. So let's start off by talking about settings. And in all reality, the settings on the chart, if you have a good quality machine, are good enough for most things with short circuit MIG, but having a good fundamental understanding of what the knobs do is going to help you to fine tune things or troubleshoot if necessary. So let me show you that. Now on any settings chart, you'll increase in wire speed with increased thickness, but also voltage. And your voltage needs to be correct for the wire speed you select. It has to do with why you get that frying bacon sound that everybody's looking for in their welds. This is some high-speed imagery that I got of a weld for a project last year, and you can see with short-circuit MIG, it goes down and short circuits against the weld puddle, melts back with an arc, and then the process repeats. And so the arc isn't on all the time, and that's why you get that frying bacon sound. It's every time you actually go and dip in the weld puddle. In other parts of the world, it's called the dip transfer mode. Here, it's often called short arc or short circuit. But this is done to control the heat so that you can weld in all sorts of different positions and gives you a bit more control. So you have to have the voltage dialed in just right for that to run, kind of like a carburetor. So look right here, if the voltage is too low, notice the wire is just stubbing out and it's not running very well. On the other hand, if it's too high, it gives a similar sound, but it's because it's burning back too far. So one of the best ways to do this is to actually run an experiment and run a little bit at a time. So you run, change parameters, and then weld again and again and again. I'm probably about to get a comment that the plate's heating up as I go, but I'm not trying to write a scientific thesis here. I'm just trying to get some settings. So that will have an impact, but it'll be okay. Let's take a quick look at each of those beads. Notice the metal's just sitting on top and the wire's stubbing out a little bit. It's not very stable running down here at 15 volts, which I know is too low. Up at 16, it gets a little bit better, but you still have the molten puddle is largely just sitting on top of the plate. And at 17, it's getting in the ballpark, right? It's starting to look about like I'd expect the weld puddle to. Now notice as I increase in voltage, the average arc length increases, so you'll see more light there happening all the time and a wetter puddle that smooths out. So in general, a higher voltage will give you a more flat puddle rather than a convex one that sticks up out of your weld puddle. We'll take a look at all these results, but notice here at the top end how much spatter you're getting, and that can be another problem. So right there you can see how it's just heaped up on the material where it's sunk in, and there's a progression throughout from 15 to 21 volts. It had that narrow arc versus that longer, wider arc. And 18 right there is a pretty good spot in the middle, but there's a range that'll be okay. And this whole exercise only took 2 minutes. Let's take a look at it on a joint here at 16.5 inches per minute versus 18. You can see how much better it wets in with that higher voltage. At 19.5, it looks nice also, but you're getting quite a bit of spatter at that point, which I don't want. So this is a real worthwhile exercise that when you go to your project, you can have confidence that your settings are dialed in. I just wanted to point out I'm running the HTP Revolution 2500. This isn't a sponsored video or anything, but I am really impressed with the machine. It does AC, DC, TIG, pulsed MIG, all sorts of things, anything you'd want a welder to do. But here you can set it with synergic settings, like a lot of machines, to where you just set it based on the thickness and the wire speed and voltage automatically adjust. And then you can adjust the trim or turn the voltage up and down for a given wire speed, just like we did in this experiment. So you might need to fine tune it for an application, and what we did before can work with synergic settings as well. Now the next 3 things we'll talk about have to do with your welding technique, and for most people this is going to give you the biggest boost in results for the time that you spend. Welding is a skill, and like any other skill, it can be helpful to break it down into its fundamental elements. You know, if I was learning a musical instrument, my wife used to teach band before we had kids, and she wouldn't take someone who was new with a musical instrument, put them in a room, say you blow in this end and music comes out here, keep working on it until it works. But that's what we do with welding all the time. So I'm trying to change that by breaking things down into their fundamental aspects. And the first one we'll talk about is your contact tip to work distance, or your stickout. For short circuit MIG, around 1/2 inch from your contact tip to your workpiece is about right, but I'm going to try running some longer ones, and we'll take a look at what happens when you do that. With an appropriate stick out, it wets in really well and the process runs like it should, but as I increase the stick out, that wire acts as a resistor and it actually will reduce the energy that I get in there. And this machine is much more tolerant than most, and we could talk about that in a different video, but watch as I get longer and longer. The pool is just sitting on top, and you'll see this really well in the results. And as I get really far here, you can see that wire heating up red hot, and I'm also getting these little Pinocchio noses growing out of the weld, and that's an indication of porosity happening inside, so I'm not getting adequate gas shielding. Now you can notice the first two, it actually could handle it with this machine. Most machines, from my experience, probably wouldn't handle quite as much as this one, but those last two, it's sitting heaped up on top, and you could see the indication of porosity there that you probably don't have a sound weld, and if you were to cut into this, you'd see little holes throughout it because that gas couldn't just get there. So watch your stick out. So we just talked about stick out, and that's gonna have the biggest impact on having everything run right and consistently as far as technique goes, but the other two elements we'll talk about matter also. Now, each of these elements I break down in further detail in my online courses, and I have practice exercises for them, and I break out the whole process multiple times talking about settings and things like that. So if you want me to walk through in a real step-by-step way, check out those online courses. But I'm going to go ahead and dive into the next thing to pay attention to, and that's your angle. It comes in a couple different directions. Let me show you how that works. Let's look at what's called a work angle, and that's how your torch relates to your plates. Now notice how shallow this is sitting, and I'm pointing up at that top plate, and this is obviously going to bias the weld up toward the vertical plate, but it's also going to cause you to miss the root here as you're punching the material mostly in above the joint, and this can be really problematic. We'll look at the opposite where I'm pointing down with a really steep angle, mostly towards that bottom plate, and you might be thinking this is really obvious. Who would ever do this? The reality is, a lot of people, from my experience, if you're not paying attention to it and you don't train yourself to watch that angle, it can get out of hand really easily. So you've got to watch it. Let's see what happens when I straighten it up. Here I want to come in at about 45 degrees. I might point a little more towards the top plate because of my welding position. But when I do this, it's going to go in much better. We can take a look at how that looks. And also we'll take a minute here and just look at the overall results. And you can see, like you'd expect, it's pointing up towards the top plate or the bottom, depending on how I faced it. But when it's evenly matched, I'm going to have the best opportunity at penetrating down to the root. With short circuit MIG, you can run anywhere from 15 degrees pushing to 15 degrees pulling, and it works out just fine. There have been a ton of experiments already done online about this. I could run some. If you're interested in that, let me know and we can make a video all about that, but it's pretty well established. So just make sure you don't get carried away with it. One of the problems with this is if you twist your wrist as you travel, you'll start to get out of whack on your angle in the direction of travel, and that can be pretty problematic. So just stay in this range, pay attention to it, and you'll be doing pretty well. Now the last thing we'll talk about is our movement or travel speed. Now, honestly, it's not about how you zigzag. No matter what you've seen in some kind of reel on TikTok about different zigzag patterns, it's not the key to success. So I'm going to show you what really matters. Some amount of oscillation is okay, and you can notice I move around a little bit, but it's pretty close to a straight line, and I stay right with the puddle. Right here, I'm running a bit too fast and it didn't fill in. Next, I'll run a good speed, and you can see this is filling in nicely. We'll look at the results once again. But finally here, I'm running way too slow, and notice how by running too slow, I'm hanging back in the puddle, and that front leading edge is just rolling over and not really heating up and consuming. So it just looks sloppy, and it's likely to have a lack of fusion defect there. Even though it'll be really strong because it's big, the center weld where I'm running the right speed is where I want to be. So if you pay attention to that, that'll help out a lot. So now that we've broken this down, what do you do about it? Well, I showed you how to run an experiment to dial in your settings, and even if things are running okay for you, it's not a bad idea to try some beads with it turned down and turned up so that you get a good understanding of what those knobs actually do, and you can recognize and troubleshoot that in reality. Now, some other things you can do are practice exercises like running beads on plate, Run bead after bead after bead. Focus on one thing. Be like, I'm going to focus on my stick out here. And after 3 or 4, you're feeling good about that. I'm going to focus on my angles. And then if you're feeling pretty good about that, I'm going to play with my travel speed and maybe a little bit of gun manipulation on the next ones. So do that, be safe, weld something, and we'll see you next time.